And recording started. Okay, so let's try to do a recap of what we talked about. So using the very question that we have, so the question that is very important is what was given in the question. Okay, so now find the value of, so from that they're saying that the roots of this equation are alpha and beta. So given that the roots of the equation that are alpha and beta, find, the first question is saying 1 over alpha, then the other part is saying 1 over what? Beta. So it's very important to understand what we said. So remember we said that whenever you are given an equation, it's very possible for you to predict the product of alpha and beta and also their sum. So we said from the equation, which is of course in the form of ax squared plus b x plus c, which is a quadratic function. For example, this one, we know our a is 2, our b is -4, then our c is 5. So we said alpha multiplied by beta is going to be c divided by a, then alpha plus beta is what? -b over what? Over a. So if you're able to remember the two equations down there, then you're home and dry. Because whenever you're trying to find any value, all you have to do is make sure that the question that you've been given should be expressed in this form, a product of a sum. So if you look at this one, which we are adding, how can we make it to be either the product of a summation of alpha and beta, somehow, so that we get to plug in and find the value? Because remember, from these two equations that we have down, it's very possible to find what alpha and beta is as a value, and also the summation of alpha plus beta, what it is. Now we together. Okay, so we're saying now alpha multiplied by beta is actually c over a. So if you look at the equation that we have, which one is our c? Our c is 5, right? Then our a is what? Our a is 2. Do we all agree? Do we agree from this equation?
Yes, sir.
Then the summation of alpha and beta, what do we get to have? -b. So our b is already negative, so multiply by the negative, it will become positive. Then again our a is still 2. So that would be 4 divided by 2, which would be a 2. Are there any questions there? Okay.
No, sir.
So how are we going to find then alpha, 1 over alpha plus 1 over beta? This is going to be equivalent to what? How do we get to make this, I don't know if it's an equation or, yeah, to make it in either the form of a product or a summation? What did we say? Okay. So it's not about you trying to master things here, it's just a matter of you trying to solve it as it is given. So if you look at this one, we are adding, so we come up with a common denominator, which will be alpha by beta. So then we have beta plus what? Plus alpha. So we've already expressed it in the form of summation and what? And the product. So alpha plus beta on top, we can plug in 2. So we have 2. Then our product is 5 over 2. So 2 divided by 5 over 2 is the same as multiplying. So this is going to be equivalent to 4 over what? Over 5. Do we all agree? Alright, so we're just working with what you already know. That is from the basic algebra addition of fractions. So you look at the common denominator, then you divide by alpha. If you divide that into the alpha by beta, you remain with beta. Then if you divide the beta there, you remain with alpha. So it's like you adding 1 over 2 plus 1 over 4. That's what we're actually looking at. How do you get to add fractions? So if you're adding 2, so the common denominator here is going to be 4. You divide the 2 into the 4, you have 2 plus 1, again you have 1 there. So that's the same concept that we are using to add these guys. Okay, so I said I'm going to answer 4 out of the questions that we have. So let's pick another one. Remember we have about, is it 8 questions? Let's pick the ones that we feel are very complicated. Of course, let me start with this one as well. I've chosen for you this one because I know most of you miss it. Okay, so basically the easiest way to express this one would be by just making it to be something like that. You put it in brackets. But then these two guys are not the same. Do we know that? They are not the same. So if you expand what is in the brackets there, what you get to have is what? You have alpha squared plus 2 alpha beta plus beta squared. Of course, I don't have to show all the steps. We know how to multiply these guys. You just have to come up with the brackets like that. Then you multiply them, right? We know that already. So that's what I've done. And that is the result. So you should be able to predict a sum by now. Okay, so now, what are we trying to say? So if these two guys are like this, they are equivalent, but we want to make alpha squared plus beta squared the subject, what are we going to have? So we're going to have alpha plus beta squared minus, so we can take this one to alpha beta being equal to alpha squared plus beta squared. So therefore the top part that we have, what can we introduce? We can say minus 2 alpha beta. So we've expressed it in the form of summation and product. So remember we've already found what the summation is and what the product is. So you're able to substitute in and find the actual values there. Do we have questions there? Have we understood? Let's pick another question. You can go to the group if you don't have the questions. There are a lot of questions where if you can't pick, then you can solve all of them. Question what? There's even question B. You are saying alpha minus beta, right? Squared. Is this one that you're asking about? Alright, so then what do we get to do? Let's try to expand the brackets. Let's try to open the brackets. What are we going to have? So obviously you have alpha squared minus 2 alpha beta plus beta squared. Does that make sense? I've expanded that. Of course, it's you can try it out. You still get what we've written down there. Okay, so we can say we have alpha squared plus beta squared minus 2 alpha beta. So what are we trying to say? So what we're trying to say in this case, we are saying the new term that we have there is already in the form that we want it to be. So it's just a matter of paying attention to this one, which we take back us to the previous question. So we said alpha squared plus beta squared is the same as what? Alpha plus beta squared. What else did we put there? Not so. Do we remember? So basically this will now even become alpha plus beta squared minus 4 alpha beta. You can even plug in from there. It's fine. These things are simple. So it's not like I've solved them. I'm just trying to look at it when you tell me which one to solve. I don't have the solutions. Yeah. So don't think that you're supposed to know it, or just think of the way in which you can express it in the summation as well as in the product. Now let's pick one more. The last one. Okay. I hope I'll solve it. 1 plus 1 over alpha squared plus 1 plus 1 over beta squared plus 1. So what do you think if you look at this one? Which way can make it possible for us to be able to put it in the form that we want it to be? So obviously, no need of you even thinking about that. Just try to, first of all, it's a try and error thing. Just add, we see what you're going to have. So if we had, obviously, we have alpha squared plus 1 as our common denominator. Excuse me. So let's try to multiply there. What are we going to have? Not really. We are adding now. So like, if you divide this into that, it's going to cancel out. So you remain with this other part. Multiply by 1, which will remain that. Then plus again, alpha squared plus 1. So we can correct what we feel it can be expressed. So we have alpha squared plus beta squared plus 2. So the top part, I'm sure we are able to simplify it from that stage, right? Because we know what alpha squared plus beta squared is. Let's try to look at the denominator then. Let's try, if you multiply alpha squared by beta squared, you have alpha squared beta squared. Then you multiply this times the 1. What are you going to have? It will be alpha squared, right? Then plus beta squared plus 1. Does that make sense? So we can now go back to, we have alpha squared. So if you look at this part, what did we say? That is equivalent to what? To alpha plus beta squared minus 2 alpha beta. So we have a 2 plus 2 over what? So alpha squared beta squared, we want to express it in either the form of the summation of the roots of a product. So we can just pull out the square root. So we have alpha beta then squared. Then the other part again, so we will still have alpha plus beta squared minus 2 alpha beta. That is representing that part plus 1 again. So from there we've expressed the entire thing into in the form of summation as well as product. So we only use the equation to find what alpha plus beta and alpha multiplied by beta is. That's all. Okay, so I've showed you how to express them in different forms. So the takeaway point is make sure you remember that alpha plus beta is negative b over a. Then you need also to know that alpha multiplied by beta is what? Is c over a. Of course, we look at quadratic functions, so of course we look at that. Okay, so I hope that helps out. Now there is another form of a question. There is another form of a question apart from this one that they can ask you under this part. I remember, yeah, we talked about it last time. So what we said is, they can tell you to say, just like we've told us in this question, to say you have alpha and beta as the roots of the equation 2x squared minus 4x plus 5. Then they can ask you to say find the equation with what? With the roots. For example, you can say alpha plus 1 and alpha plus, or beta plus 1. This is an example. So these are the roots of a new equation. So find the equation. How do you go about it? So we said these guys, you need to first of all add them. For example, in this case, they are going to give us what? You have alpha plus beta plus what? Plus 2, right? That is after addition. So we can say that's what we have after adding the roots. Then after multiplying them, you have alpha beta plus alpha plus beta plus what? Plus 1. So these are already in the form where you can plug in, right? Do we all agree? So if you go back to the equation there, what is our alpha by beta? It's c over a. So our c is 5 over 2. Then our alpha plus beta, we said it's a negative of b, so it will be 4 over 2, which will be a 2. So in this case, alpha plus beta will put a 2 plus a 2 will give us a 4. Then down there, what are we going to have? Alpha plus multiplied by beta is giving us 5 over 2 plus this part where we have alpha plus beta will put a 2, then plus 1. So we have 5 over 2 plus 3. So what do you get if you add those guys? So 2 by 3 is 6, you can agree. Then we have 11 over 2. Yeah. So we have 11 over 2. So now we've found the product and also the summation of the new roots. So how do you get to find the equation now? So remember what we have is, for the summation we are saying we have what? We have 4. What do we have for the product? For the product we have what? 11 over 2. So the idea is to make sure that if you look at the formulas, we said alpha multiply plus beta is negative what? B over what? Over a. Then the product we said is what? C over a. So this means that these guys are supposed to have the same what? They are supposed to have the same what? Denominator. Are we together? Now in this case, are they the same? No. So we'd want to express the other one in the same form. So you can add that one to B. So 4 is the same as what? In terms of adding a 2. So think of something that you can put on top. If you divide, it gives you a 4. 8, right? Do we get that? The idea is to have the same what? The same denominator there. So we can therefore say that our B is negative 8. Our A is what? Is 2. Then our C is what? Our C is 11. So since we know what the constants are we not able to find the equation? So we have ax squared plus bx plus c. Our a is 2. Our b is negative 8x plus what? Our c is 11. That's a new equation. So that's another form of equation that you can have apart from the one that we are from solving. Have we understood? So that was just like kind of a recap. And, yeah, I hope we've understood. So last time I promised that we are supposed to start talking about what? What did I say? Last time I said we are supposed to start talking about the polynomial functions. That's what I said. Yeah. So we need to look at long division and what? And synthetic division as a lesson for today. So I'm trying to get some questions now. Let me just got the past papers, that's all. The only good about universities, it's not as hard as high school. But it's hard, but it's not as hard as high school, because high school requires you to know the things in a period of 3 years, but they expect you to know that within a year, and they expect you to write an exam. And the good part is when you write an exam at the end of the year, they'll never ask you again. That's all. That's the only good part. But the other part side is they expect you to learn a lot of things within a very short period of time. But molecules. No, like what I mean is being assessed on them based on the fact that you learned them in your first year. I don't know if you get that. Unless if you get to learn them again. That's when they can assess. Not that you learned it from first year, then they come and ask you. Doesn't work like that. In short, teacher is independent of course, they wouldn't teach you to, I don't know. I'm not doing medicine, so you can find out more. Yeah. But they don't ask you based on the fact that you learned it in your first year, unless if you get to learn it again. Yeah. As a doctor, you don't have to forget, because, yeah, no. So that's our startup question. So what we need to understand is we need to know how to divide using long division. Then we also need how to know how to find the factors, which is actually just basically the same. Okay. So we also need to have be able to find the factors. I think that's what is very important. Yeah. That's all. That's all. They can only ask you to factorize. They can also ask you to find certain values that, of course, are going to be based on the same. So let's start with this very question, and we see the way we can. So let's try to factorize it and also solve it at the same time. So we can start with long division first of all. So up to now, no one has found an equation that you can use to find the values of x in a polynomial function. Up to now. So if you can find it, you can become a mathematician and people start learning about you. The only equation that is there is for a quadratic function, but for a polynomial function, there is no equation. So basically, as you get to look at the first value of x, it's a try and error thing where you try to guess and try to predict what can give this equation a 0 when you plug in there. So usually we get to try values between -4 to 4, but basically most of the times the possible solutions are just between -2 and +2. So if you don't find them with between -2 and 2, that's when you can move as far as 4 and -4. So let's try to start with something small. We start with -1 and 1. So I think 1 is the easiest thing to start with. So if you say 1 cubed is what? So we have 1 minus 3 minus 10 plus 24. So obviously, if you look at this, do you expect this to be 0? Because of course this is -13 plus 25. So it can give us a 0, right? Let's try maybe, how about if you try -1? If you try -1, we have -1 there. Then there we have -3, where there we have 10. So this is actually now giving this one an advantage. So it can be cancelled out by the negatives. So it's not possible to get a 0. Let's try 2. 2 to the power 3 is what? It's 8. Then 2 squared is 4, right? 4 by 3 is what? 12. Then again, if you put a 2 there, it will be 20 plus 24. So -12 plus 20 is what? -32. 24 plus 8 is what? So this is a 0, right? So 2 is a possible solution, right? So whenever you say that f of 2 is 0, then it's a factor. So whenever 2 is a factor, how do you get to express it in terms of the brackets? You can say it's x. So you can say, okay, our value of x is equal to 2. If you put it there to give you a 0. So in terms of a factor, you write it as x minus what? 2 equal to 0. That's how you get to write it. Are we together? Are we together? Are we together?
Yes, we are.
Okay, so from this stage, you make a decision whether to go by synthetic division or long division to find the other factors. So for synthetic, you work with this. For long division, you work with that. So we can start with long division, right? So divide by x there. That's the way you get to move. You get to divide by x. So if you divide x into the x cubed, it will be what? X squared. You multiply that with the whole thing there. So you have x to the power 3 minus 2x squared. Then from our long division, we know that at that point you subtract. So -3x squared minus 2x squared, it will end up to be minus x squared, because what we're looking at is this. So you have negative 3 plus 2, right? Are we together? So x to the power 3 minus x, those are going to give us a 0. So yes, again we are supposed to divide. So what we have there is supposed to be divided by what? By the x. So if you divide by the x, it will be minus what? Minus x. Multiply the other side, you have minus x squared plus 2x. So I've dropped that. We are subtracting again. So as usual, this will cancel out. Then the other part, negative 10x minus 2x. What are we going to have? What are we going to have? Negative. Okay, negative 12x. So we divide by the x, we have minus what? So we divide this part by the x again. We multiply, again we have minus 12x plus 24. We drop a 24 there. Again we come and subtract. So we have a 0. Okay. Do we have questions there? Do you have questions? So basically what we are saying at this point is we've come up with x minus 2. If you multiply it with the value that we have on top here, it's supposed to give you that equation. You can try it out if you want to. So now we have x squared minus x minus 12. So is it possible to factorize that one? So our product is 12 minus 12. Our sum is negative 1. What values can you multiply to give us negative 12? Then if you add them, they give you minus 1. Three and 4, right? So negative 4 and 3. So we have x squared minus 4x plus 3x. Are we able to see, by the way? Are we able to see? Guys, can you get me?
Yes, sir. Yes, very clear.
Then the board. Okay. So if you factorize the x from this part, you have.
Yes, sir. Same here.
Then the other part, what do we have? We can factorize 3 from there. You remain with x minus 4 as well. So in terms of the factors, we have so far we have x minus 2. So now we have x plus 3. We also have x minus 4. So if they ask you to factorize, you can end at that point. You've already factorized. But if a question says solve the equation, you have to find the actual values of x. So x is equal to 2, x is equal to negative 3, x is equal to 4. That's it. If you have got aquatic functions, you're supposed to have 4 solutions. the same process applies. You just have to, but then for the quadratic function, you are going to, if you divide by a factor, you are going to find a cubic function. So again, a cubic function, you solve it the same way we've solved this one. Again, you come and solve now the quadratic function. There are times where the quadratic function that you find, you can't factorize it, so you just end at this point. They'll mark you because you can't factorize the quadratic function. Meaning that that quadratic function that you've come up with doesn't what? Doesn't have real roots like we mentioned in the other lesson. Are we together? Pardon? No need of you doing that, because most of the times they'll give you something that is that you can factorize. So unless if it refuses, that's when you can now test to really prove that okay, it can't work out. Alright, so are we together there? Have we gotten the concept? Let's try to look at the same question again. In terms of synthetic division, how do you get to do it then? So what was the equation that we had? We had x to the power 3 minus 3x squared minus 10x plus 24. That's what we have. Then what are we trying to say? We're trying to say our first factor was what? X is equal to 2, right? It's the one that gave us a 0. So for synthetic division, excuse me, you can put a 2 there. Then write the coefficients of the entire equation. So there's one thing that I didn't mention. So there are cases where, for example, they give you x to the power 3 plus 24. So whenever you're dividing using long division, it's advisable that you introduce imaginary parts in between, so that the powers are reducing in the order in which they should, to make it easier for you to work it out. So this would be for long division, but for synthetic, you just get the coefficients, you put the zeros. Of course, I'll give you a practice question on that. So what we have now is 1. There we have what? Negative 3. Then there what do we have? And 24. So the first step is to drop the first factor, 1. Then we'll be multiplying by 2. Then here we'll be adding. Before I even move on, have you followed what I've said? Pardon? What are you saying?
Yes, sir.
What have you where exactly? Where exactly? Yeah, so I've talked about a lot of things.
Okay, I've gotten the part for the coefficients where you
So the first step is to
I've gotten the part that you get the coefficients there at the first bracket.
So now the first step is to drop the 1. The first coefficient is supposed to be dropped down. From there we'll be multiplying by 2. So 1 multiplied by 2 is what? You have a 2. You had now. Negative 3 plus 2 is what? Negative 1. Multiply by 2. Mm-hmm. Hello? I'll help you out. It's negative 2. Negative 10 plus negative 2? Negative 12. Then negative 12 multiplied by 2? Negative 24 plus 24? So the last part is the remainder. So in a case where they give you a question to say, determine whether, for example, they tell you whether x plus 2 is a factor of that function, you can use synthetic division to try it out. If it gives you a remainder of 0, then you can therefore make a conclusion to say it's a factor. Then another way to try it out is by plugging in the value. So in this case, you make x a subject, you say x is equal to negative 2. So you say if the function of negative 2 is equal to 0, then it's a remainder. So you plug in negative 2 in the function. If it gives you a 0, then it's also a factor. Or you can also divide using long division. If you get a remainder of 0, then it's a factor. Are we together? Are we together when to tell whether it's a factor or it's not? So in this time around, what we're going to have, this is our equation. Those are the coefficients of our equation. Then the power is supposed to reduce by 1. So the highest power that we had in that question was power 3. So we'll start with power 2 and the 0x. So what we have is x squared minus x minus 12. Are we together? So this is exactly what we got using long division as our factor. Then from there you can also factorize it. Yeah. Are we together? Have we understood?
Yes, sir.
Yes.
Alright, so we end here for today. I'm sending you some practice questions, starting from the alpha and beta up to these functions as well. If you'll be able to solve the questions, then home and dry. We can see what we can do tomorrow. And when do we have math? We have math tomorrow. How was the timetable made, guys? Do we have math tomorrow? Tomorrow is Sunday. Oh, tomorrow tomorrow is Monday. Okay, so Tuesday. Okay, she said. So tomorrow I don't have a class. Better off. So I can make some videos then on the practice questions on these guys, the alpha and beta together with the polynomial functions. The timetable has been the DP of all the groups that you are in. Yes, recorded. I'll share the link. So alright, this time around I'll be recording all the classes, so don't worry much. Alright, so have a good evening and study well.